Hello, I hope everyone's doing well today. We are going to continue on with our solving multi-step equations lessons, and we are going to move on to our lesson 4, which is solving multi-step equations with variables on both sides, and then also looking at special cases there. This does line up with book topic 1-3 instead of 1-4, just because we split some of the other topics up. The steps should look familiar because they're the same steps we followed in lesson 1.3. Distribute through all parentheses, combine like terms on the left side, combine like terms on the right side, move the variables to one side, move the numbers to the other side, and then solve. Couple things I want to point out again. For steps 2 and 3, we don't cancel when we're combining like terms, but 4 and 5, when we are solving and moving them to the other side, we do cancel. So think opposite side means we do opposite operation. Same side means same operation. So I'm not going to change this. Okay, so let's look at this first problem here. Zoom in a little bit. So we are going to start by drawing a line through the equal sign. And I know we've mentioned drawing this line to make your life easier in the future. This is the future. These problems get a little bit more complicated, so it helps us to kind of keep our work straight if we draw that line. So first step, distribute through all parentheses. So I don't have any parentheses on the left side. I'm going to bring those straight down. But on the right side, I do have parentheses. So we're going to go ahead and distribute. So we're going to do -2 times x, which is -2x, and -2 times -4, which gives us a +8, because when I do a negative times a negative, I get a positive. Since that plus sign isn't in parentheses, we're going to bring that straight down. Okay, our next step, whoops, do a rectangle there. Our next step is to go ahead and only focus on simplifying the left side. So I'm going to cover up the right side for right now, and then we'll come back to it. But on the left side, we are going to combine like terms. Now, if they're on the same side, we use the same signs that we see. So notice I have like terms here. I have a 3x and I have a +4x. So if I combine those together, 3 and 4 give me 7 x's. Since there's nothing to combine with that 10, we're just going to bring the -10 down. So that's simplifying the left side. I'm going to move this box over. We're going to ignore that side now, or the one below it. And we're going to focus on simplifying the right side. So I noticed that I don't have any other x's, but I do have a +8 and a +9. So I'm going to go ahead and combine those two together. Since there weren't any x's, we're going to go ahead and do -2x, sorry, -2x, and bring it down. And then 8 and 9, +8 plus 9 gives me a +17. Okay, so I didn't change any signs there when I did that. I just combined them together. Now, steps 4 and 5 talk about moving the variables and the numbers to certain sides. Mrs. Straight, when she helps you, will often show you this, but she likes to label this the letter side with an L and the number side with an N. So if there's a letter on the number side, we need to cancel it out. So this -2x needs to move over to the other side. And I'm going to line it up with the other x so I can combine them together. Now, since they're on opposite sides, I had to do opposite operations. So 7x and 2x gives me 9x minus 10 equals 17. Okay, again, there aren't any letters left on the number side, but there are some numbers on the letter side. So now we need to move that -10 over. And this is really just a two-step equation here. The opposite of -10 on both sides, since they're on opposite sides, or our time to cancel them to move them, is +10. So 17 plus 10 gives me 27. And then if we divide by 9 on both sides to get the x alone, we get x equals 3. The next one, we're going to do the same thing. We're going to draw our line through the equal sign. And then I'm actually going to show you a little bit different strategy because there's a fraction in there. And I know a lot of you don't like fractions. So what we could do is we could multiply everything by the denominator of the fraction, which is 2. And it'll get rid of our fraction for us. So if I do 2 times this whole part, and then 2 times this, and 2 times this, and 2 times this, I'm allowed to do that. It's kind of like distributing, and I'm going to show this a different way. Whoops, didn't want to do that. Okay, so we're going to go ahead and put parentheses around this because we're really multiplying 2 times everything. So for the first term, 2 times 1/2 actually cancels to give me 1, or just n minus 4, or 1n minus 4 if you want to put that there. And this is one whole term because there's not an addition or subtraction sign outside the parentheses. We're going to do 2 times -7, which is -14. We're going to do 2 times -2n. Yes, we do it across the equal sign, so 2 times -2n is -4n, and then 2 times 6. So just like our distributive property, multiply everything by 2, and that's okay. Now, 1 doesn't impact anything when we multiply, it doesn't change it, so I'm actually going to get rid of that. We don't really need it. Let's look at the left side and combine our like terms. So if we're just combining like terms because they're on the same side of the equation, -4 and -14 give me -18. On the right side, I can't combine anything together because those aren't like terms. I'm going to make this my letter side and this my number side. So I need to move that letter over to the other side, so +4n on both sides. If you want to add a 1 there, you can. So 1n and 4n is 5n minus 18 equals 12. Now we need to move the numbers over, so we're going to do +18 on both sides to get 5n equals 30. Scroll down for a second. And then we need to divide by 5 on both sides. Okay, and that's it. There's a couple eutriots here. We'll kind of talk about those in class to make sure you're okay with those. We're going to do 2 more because these are some special cases here. Let's go ahead and draw our line through our equal sign and get rid of any parentheses. So we are going to distribute on the right side, and the left side is going to be the same. So if I distribute, I get 4x plus 6 here. Hopefully you notice right away that the left side and the right side are the same. What that means is no matter what x value we pick, it will always work out. Okay, so if I move my letters to the same side, everything cancels and I get 6 equals 6. Okay, this is a special case because these cancel here, and all of our x's disappear. This is called infinite solutions. And I'm going to write a symbol, infinite solutions, that we would take, so you don't have to write it all out, or you could type out infinite solutions. Okay, either one of those would work. Let's look at the second one. When we draw our line through the equal sign and then distribute for this one, we end up getting that 6x minus 5 equals 6x plus 8. This time, when I cancel my x's out by subtracting 6x from both sides, you'll notice that when they cancel, I end up getting -5 equals 8, which isn't true. So I'm going to put a not equals 2. This is not possible. -5 will never be the same as -8. So our answer here is actually no solution. Or what we call the empty set for a symbol. And those are our special cases. come on back for the next video and we'll do some application problems. But go ahead and get some practice done on these and let us know if you need help. Have a great day.